We are on the section 4.6, page 32. This one is a little bit different from previous sections. Previously, what did we do? We give you an equation, then you graph the line, right? So we have three methods, and which three methods we use? Not on your paper, right? So we did what? We use t-table with how many points? 3 points, right? 3 points. Then second one, we use what? T-table with how many points? 2, special 2 points, right? 0, 0 for the intercept, right? Then third method we just learned, which was what? Using slope intercept form to graph it, right? So you have 1 point here for the y-intercept, then use the rise over run to find another point, right? We did this. Now we are going to do opposite. We are going to write an equation, okay? We are going to write an equation, and when we are given slope and y-intercept, that's first. Then we use other ways to write the equations as well, okay? So for the first one on your page 32, we said if you have a slope given, right? Slope and the y-intercept, you should be able to write the equations, right? So, because you can see the equation formula is already given to you right here, right? If slope is 5, slope y-intercept is b, right? It's -3. What do you think? You just plug in, right? So for your equation, usually you have y and x. Then slope is 5, intercept, y-intercept is -3. That's all you need to do, right? If the slope and the y-intercept is given to you. So if slope is -½ intercept is what? 0. So what do you think? That would be y equals -½ x plus 0, right? Whether or not you put the 0 there, it's the same. So if your slope is given as 3/4 and y-intercept is 2/3, you will write what? Y equals 3/4 x plus 2/3, right? Straightforward. So what happened to other situation if the slope is not given to you and you have other kind of information? Then how you are going to write the equation, okay? So take a look. If we said situation like this, if 2 points are given to you, say if you are here, right? Your target is here. Then if you shoot a straight line, try to go through there, then what kind of line that would be. Say, like we are here, if we shoot a Patriot missile, try to shoot the target here. That would be really complicated because we have gravity and other things. But we start from here, all right? If we want to shoot a straight line, right? Then how do you program your machine to follow the line to get to the target, right? So then you will write the line first. So how would we do that? So for each point on the line, that would be what? X and Y's, right? Both X and Y's. And to differentiate them, what do? We will write a subscript. So this is point 1, then you say x1, y1, right? And point 2, you will say x2, y2. Okay, so if you are here, it's given. This is a given, all right, given position. So if this point, any point on the line, we just say X and Y's, right? If we say you want to program your machine to write this line, that means you want to write any point along the line, which would be what? X and Y, right? So this one would be any point on the line. Okay, so the way for you to do it is use this formula. So any equation, for the linear equation, we will have y and x, okay? And the x1, y1 is a given position. So you will write y1 minus x1, okay? At the same time, we want to know, your target is which direction, how steep it is or how shallow it is with a slope, okay? So that's how you would do. You will put the slope here. So that will be your formula. If you know a position where you started, we call it x1, y1. And if you know how steep your slope would be, okay, then you can write the equation according to this formula. So x and y are your two variables, right, of the linear equation. Then m is your slope, right? Then x1, y1 is a non-fixed point given. If we give you a point, we want to start from here, then you want to shoot a line according to the direction you want to go and how the slope would be to decide your direction. That would be the formula you want to use, right? So far we learned 3 formulas for a line, right? A linear equation. First one was what? Standard form, right? Second one was what? Slope-intercept form. Now we are learning the third form. Okay, those forms are the result. And the third form you are learning, we call it what? Because we have a point given, then we have a slope given, so we call it what? Point slope form. This form is only a intermediate stage, okay? So if you get this form, you have to convert them to the standard form or slope-intercept form. So let's learn this one, how we are going to apply the new form we just learned, okay, to write an equation with standard or slope-intercept form. Okay, so let's take a look at the first example. Let's do it on this side. Because I wanted to compare two different things for you. So usually you will mingle them, okay? First one example, if a point 0,3 is given and your slope is what? M equals half. How would you write your equation? The next one, point -1 and 3 is given. You have same slope, right? How you are going to write the equation. So let's take a look. For the first one, 0, 1, 2, 3. So that's your 0, 3, right? Another point is what? -1, 3. So this point, let me write it here. Another one is what? -0.3. So this one is -0.3. So it says the slope is what? Half. So for the first one, right? So this is the second problem. So for the first one, the slope is what? Half. Both are half. So it means what? These two lines are parallel, right? So 1/2 means what? Rise 1, run over what? 2. So first line would be like this, right? And the second line would be what? Rise 1 over 2 would be like here. So second line would be like this. They are supposed to be parallel. They are different lines, right? So for the first one, I have point here. What kind of point is this? Is that the y-intercept, right? So if you have y-intercept, can you just plug in this formula for the first problem? You keep your y and x, right? Then what's your m? Half. What's your b? Is that b? Plus 3. Then you are done for the first question, right? For the second one, can you do the same thing? You say, oh, okay, my y is half of x for the slope. Then you just put a b because y is 3. You just write this one. Can you do that? Are they the same? Right? You can't because they are different lines. And for the second one, and there, its y-intercept is not 3. It's somewhere here. So you cannot directly plug into mx plus b to write your equation. So what do you need to do? You have a point given, you have slope given, so you can use point slope form. So what point slope is saying? Y minus y1 equals what? M times x minus x1, right? So you keep y and x. That's your variable for the equation. What's your y1? So given point is x1, y1, right? Given point x1, y1. So you plug in y1 for 3. Then you plug in what? x1 for -1, right? So then what's your m? M is half. So that's how you will plug in. So then you will write your equation this way. Y equals, y minus 3 equals half times what? X minus -1. Don't forget, minus x is -1. Right? But you don't write the answer that way. You need to finish up, clean up. So how would you do? You will write a minus 3 equals what? Half times x plus 1, right? Negative, negative. Then you distribute, you have y minus 3 equals what? Half x plus half, right? Then we will write it in what kind of form? Final forms would be either of those. Let's do slope-intercept form first. So you will plus 3, right? So you have y equals half x plus what? 3 plus half, 3.5. But we don't write the, mixed number. It looks like mixed multiplication. Usually we prefer to write it as what? Improper fraction. 3 times 2 plus 1, 7, 7.5. Right? So that's one of the answer. If you write it in standard form, that means what? You have to put x and y on the same side of equation, equal sign. So you do that. Right? So you will have what? Half x plus y equals what? Let's don't do that. And 7/2. So you have 2 ways to write your answer. Got idea? Okay. So if you get confused on this one, you can let it go. And you still can get your regular grade, ABC, if you do everything else right. Right? But it's manageable. Okay? So practice on that, you'll be okay. Most of the students are okay on this. But some of them, got confused with those. Just take your time and kind of connect. Next one, find an equation. The line goes through what? 1, 3, and 5, and -2. Okay? So you do the picture first. See what happened? So where is your 1 and 3? 1 and 1, 2, 3. Right here. Right? Right here. 1, 3. Another one is a 5, 2. 1, 3, 4, 5, and 5, -2. -2. 5, -2. Right? So your line looks like this. Right? So, do you know your y-intercept? No, so you cannot do it directly. Even, okay, we don't know the slope either, right? So what should we do? The equation is telling us you need to have a point. We do have a point, right? We'll say that's our point. But we use the point slope form. We need to have a slope. But right now, do we have slope? Not yet, right? We say slope is what? Slope is the rise over run. So this slope is positive or negative? Going down is what? Negative. Then you can just count it, right? Rise is what? 1, 2, 3, 4, 5. So it's going down, so you have -5, right? And run over how many? 1, 2, 3, 4. So it's 4, right? So your slope is what? -5, 4, right? So if you are given 2 points, then you want to find the line. First, you have to find the slope so you can plug in, okay? Another way to find the slope, we say you can do this one. Slope is what? The differences between the rise and differences between the run, right? So you can do y2 minus y1, x2 minus x1. Or we can do what? y1 minus y2, x1 minus x2, right? You can use that to find it as well. If easy one, you can just count it, right? So if this is x1, y1, this would be what? x2, y2, right? So if you plug in, y2 would be what? -2 minus y1 is what? 3, right? Then x2 is what? x2 is 5, x1 is 1. So what do we have? -5 over 4. Do we have same thing? Yes. Right? Or if you use y1 minus y2, let's see what will happen for this one. y1 is 3 minus y2. So you can write a 3 minus -2, right? Or x1 minus x2, that will be 1 minus 5, right? So 3 minus -2 is what? +5. 1 minus -5 will be -4. Are they the same? Yes, -5/4. Right? You can use either one, or you can just count it as what? Rise over run to get your slope. Once you have a slope, then you have a point. Can you plug in to the point slope form, right? Point slope form say what? You have a y, you have an x. Then you plug in other numbers. So what's your y1? y1. Mark your x1, y1. Otherwise, you will kind of mingle all the points and numbers. Okay? So you mark along the side of the points so you know who is whom. So y minus y1 is 3. And slope, you got it? It's -4/5. Oh, no, 5/4. Right? Minus what? x1. What's your x1? It's 1. Right? Then you need to clean up and write the final form in the standard form or slope-intercept form. So you distribute them. So what do you have? Y minus 3 equals -5/4 x plus 5/4. Right? Then you add the 3. So y is what? Negative 5/4 x plus 3 and 5/4. You don't leave number that way. Write it in what? An improper fraction. So 3 times 4 is 12 plus 5 is what? 17/4. Right? Good. Or we write it in what? Standard form. So you will add 5/4 x on both sides. So final answer will be what? 5/4 x plus y equals 17/4. You can write the answer either way. Good? Okay? So, what are we doing? We are learning the third form of a linear equation, right? Let's see. Next one. Next two are special cases. What are special cases? What do you think? Not a slant line, not always have both x and y, right? Y is missing, that would be the special case. So let's see. Number 4 is say what? A line pass through -8 and 2 and pass through here, okay, and parallel to what? To x-axis. So take a look. Okay, remember we did this. If x is 5, what kind of line is that? Vertical or horizontal? Y is free, means going up and down, right? Then that would be a vertical line. That's your x is 5, right? No y's, that means y is going up and down freely. So if here, that would be what? X equals -3, things like that. And if y equals 5, that means no x's. That means x is free to run, but x is what? Going left and right, so that will be what? Horizontal line, right? If y equals what? -3, that would be like this. So, for this one, how you would do? Instead of doing plug-in point slope form, it gets complicated. You need to graph them to figure out what's going on, right? So first, you locate -8 and 2. So here is -8 and 2, -8 and 2, right? So if you want to parallel to the x-axis, that means you need to align passing through here, right? Like this way, and parallel to axis. So what do you think? Should you have a vertical line or horizontal line? Because parallel to x-axis should be horizontal. So that's -8, that's 2, right? How do you write your line? You can just write it directly. So you use this horizontal line, right? Y go through wherever. So this line would be what? Y is 2. That's how you do. Okay? If we want you to write a line parallel to go through this point, if it's parallel to y-axis, right? Then it would be like this, right? So what kind of line is that? That would be vertical line. You have to write it like this. Y is 3, right? So the answer should be what? X is, go through here, that's negative 8. You should write it this way. Right? And take a look next one. If we have, oh yeah, we did this already. That's this way, right? Line contains going through this point and parallel to the y-axis. That's this one. Is that right? So think about it. What do we have been talking about on this section? We are doing the opposite as before. Instead of give you an equation and ask you to graph it, we have 3 methods, right? To graph it. Now is what? We are giving you a point and a slope, then ask you to write what? An equation. So we are doing opposite, right? Okay, that summarizes what we have been doing. Okay, look at your page 33. Say, let's review. What is a standard form? That would be what? Ax plus by equals c, right? Then we say a, b, c are real numbers. And a, b cannot both be 0. If you both a, b are 0, then you don't have x, y, either one, then there will not be a line, right? What do we use this for? We can use this to graph a line, right? Then we also use this to what? Write an equation. We have been doing that, right? So we also learn another form, slope-intercept form. How does it look like? Y by itself, right? Y equals mx plus b. M is your slope. Y is your what? B is what? Your y-intercept. Okay, so this one, same thing, we can use it to graph a line, right? Also, we will, to write the equation, when do we use it? When we have the slope and we have what? Slope and the y-intercept are given to us. Then we can just write it directly, right? Then another form we have learned is what? Point slope form, intermediate form, right? So which is what? Y minus y1 equals your slope times what? X minus x1, right? So m is your slope, right? Then x and y are your variables, right? Then x1 and y1 is a known point given to you. Then you can just plug in this. So what do we do with it? You know, how do we use it? We will use this to find what? The equation, right? When you have 2 points are given. If you have 2 points are given, we just did, right? to find the slope with the 2 points given, then you can plug in, then use one of the points to plug in to write the equation, right? Then 2 special cases. One is horizontal line. One is what? A vertical line, right? But you know it's what? X equals something, Y equals something. Horizontal line means what? Like this. Then X is running free. Any number, that means Y is fixed. So you say Y is B, right? So we use this for what? To graph a line. Can we do that? Right? Or we can use to write a horizontal line passing through a point, right? Just like that. If we use this one to graph a line, or we can write the equation for the line, horizontal line, passing through a point, right? For the vertical line, and Y is running free, right? Any number, so you don't have Y, so you have X equals, say, a number, right? What do we use it for? We can to graph a line with that, a vertical line, or we can do what? To write what kind of line? Actually is what? A vertical line, right? Passing through a point. Did we just do that? Right? Okay, so that's how we write the equation for a line. Okay, a linear equation. So that would be our section 4.6.